let's take a look at some other logarithmic properties. We have one called the product rule, and what it essentially says is that when you multiply powers with the same base, you add the exponents together. If you remember our property of exponents that said something like this: 2 to the x times 2 to the y is equal to 2 to the x plus y. Okay, well, we're going to try to show this property is true using a numerical example, and then I'll go into a little bit about kind of the background behind it. Okay, so log base b of m times n is equal to log base b of m plus log base b of n. So what about log base 2 of 4 times 8? That's log base 2 of 32, and so 2 to the 5th equals 32, so that side is equal to 5. And we want to see if this is equivalent to log base 2 of 4 plus log base 2 of 8. Log base 2 of 4 is 2, and log base 2 of 8 is 3, and when we add those exponents together, we get 5, and so this equation holds. Okay, well, let's examine this formula just a little bit more in detail. Okay, so I'm going to say that x is equal to log base b of m, and y is equal to log base b of n. Okay, and if we convert this to exponential form, we'd say b to the x is equal to m, or b to the y is equal to n. Well, what if I multiply m and n? Okay, so we get m times n equals b to the x times b to the y, and using that property of exponents, that's b to the x plus y. Okay, so all together we have b to the x plus y is equal to m times n. Now let's go backwards and write this in logarithmic form. So that'd be log base b of m times n is equal to whatever the exponent is, x plus y. And lastly, instead of x, we'll substitute log base b of m, and instead of y, we'll replace it with a log base b of n. The quotient rule says log base b of m over n is equal to log base b of m minus log base b of n. Or in other words, this is similar to the quotient rule for exponents, which says when you divide powers that have the same base, you subtract their exponents. Okay, so this numerical example, log base 2 of 32 over 4 is log base 2 of 8, and that is just 3, since 2 to the 3rd is equal to 8. And we're going to see if this is equal to log base 2 of 32, which is 5, minus log base 2 of 4, which is 2. And 5 minus 2 is equal to 3. Okay, the power rule says log base b of m to the n is equivalent to n times log base b of m. Okay, now this one is easy enough to kind of show, so why don't we look at an example. Log base 4 of 2 to the 3rd. Expanding that power, we get log base 4 of 2 times 2 times 2. And now we can use the product rule. And so that says that this is log base 4 of 2 plus another log base 4 of 2 plus one more, okay, which is just 3 times log base 4 of 2. Okay, so in short, we see that this exponent really just became the coefficient. And a numerical example, log base 2 of 4 to the 3rd is equal to 3 times log base 2 of 4. Okay, we can see how these are truly equivalent by just calculating. So 4 to the 3rd is 64, and 2 to the 6th is 64. So that's going to be 6. is equal to 3 times log base 2 of 4, which is 2, and 6 does equal 3 times 2. And one more property, the one-to-one property, says log base b of m is equal to log base b of n. Then the arguments have to be equal, so m is equal to n, or vice versa. So if m equals n, then log base b of m is equal to log base b of n. You can take log of both sides. Now b does have some stipulations. Remember that b has to be greater than 0 and should not equal 1. So if log base 2 of x is equal to log base 2 of 16, we see how the bases are equal, and therefore the argument should equal as well. So x must be 16.